It's a cold, gray November morning, and once again, grade 9 students are listening to their teacher drone on about some seemingly useless concepts in mathematics. Although the math itself demands intense concentration and effort, often the most challenging part of the course is simply staying awake. The students do their best to remain engaged, constantly seeking ways in which these abstract topics might play a role in their lives outside of the classroom. Unfortunately, the apparent lack of any meaningful purpose to their studies frequently leaves the young learners feeling frustrated, disappointed, and bored. But then, one day, while working on some mundane classwork, Angelica, Jocelyn, and Natalie came up with a plan to investigate the use of the mathematics they've been learning in an adventurous and intriguing discipline: the field of aviation. They couldn't wait to explore all the ways in which the equations, ratios, and rates they'd been studying applied to the real-world practice of flying an aircraft. Full of excitement, the trio immediately began planning the details of their investigation. The group agreed that they would only need a short flight in order to witness a great deal of the math that plays a role in aviation. They decided to take a small plane from their home city of Brantford to the nearby town of Tilsonburg, and then return to Brantford. Upon acquiring a genuine aeronautical map, the group was already presented with a way in which mathematics can be used in aviation. On this map, Angelica drew a straight line from the Brantford airport directly to the Tilsonburg airport. Using a ruler, she measured the length of this line to be exactly 8 centimeters. Noticing that the map uses a scale of 1 to 500,000, she was able to determine the true distance from the Brantford airport to the Tilsonburg airport. Let's take a look at this problem more closely. Once again, the aviation map uses a scale of 1 to 500,000, and Angelica measured the distance between airports to be 8 centimeters on the map. Her task was then to determine the actual distance between the airports in kilometers. Can you determine this distance? If you arrive at an answer of 40 kilometers, congratulations, you are correct. A full solution to this problem is available later in this video. The girls are ready to head to the Brantford airport, but there's one more thing they need to find before taking off: a pilot. Captain Eugene Hardapple is arguably the most experienced and highly skilled pilot on the planet. A retired military pilot, he has flown as a captain in the Spanish Air Force, the United States Air Force, the Royal Canadian Air Force, and the Royal Australian Air Force. He has flown everything from A-10s to Airbuses, Bonanzas to Boeing 787s, CBs to CF-18s, space shuttles to whatever this thing is. He has also been a respected captain with numerous airlines, including US Airways, British Airways, Kenya Airways, Air Canada, Air India, Air France, and even the prestigious Air Brantford. Unsatisfied with the adventure offered in all of these positions, Captain Hardapple decided to dedicate his future to giving local sightseeing flights in a Cessna 172. When Angelica, Jocelyn, and Natalie discovered that he was readily available to pilot their expedition, they immediately headed to the Brantford airport and geared up for the flight.
Brantford traffic, India November Sierra lining up runway 23, will be climbing to 3,000 feet, departing to the west.
Well, we're in the air.
Oh my God! Woo!
While climbing to the cruising altitude of 3,000 feet above sea level, the girls used their GPS-equipped iPads to take some measurements. They quickly realized how these measurements relate to the math they'd been studying at school. Let's take a look at what they found. The group recorded that when the aircraft was still on the runway, its altitude was 815 feet above sea level. Furthermore, they found that the plane was climbing at a rate of 900 feet per minute. The girls quickly saw a connection between these values and their study of linear equations. Can you create an algebraic equation to model the aircraft's altitude while it is climbing? Can you then use your equation to determine how high the plane would be if it had climbed for 10 minutes? If your answers are A equals 815 plus 900t and 9,815 feet above sea level, well done. Full solutions to these problems can be found later in the video. Let's consider one more important problem based on the equation. Can you determine how long the aircraft must climb to reach the desired altitude of 3,000 feet? Your answer should be approximately 2.4 minutes. If you're not sure how to find this answer, check out the solution later in the video. As the girls and Captain Hardapple continued to cruise toward Tilsonburg, Jocelyn was curious about the speed at which they were traveling. Looking at the instruments on her iPad, she saw that the aircraft was flying with a ground speed of 200 kilometers per hour. Using her knowledge of rates and ratios, she knew she could use this measurement to determine how long the flight to Tilsonburg would take. Once again, the aircraft was traveling at a speed of 200 kilometers per hour. Can you determine how many minutes it will take the group to cruise 40 kilometers from Brantford to Tilsonburg? If you calculated the correct answer of 12 minutes, congratulations. As always, a full solution to this problem is available later in the video. The crew soon arrived at the Tilsonburg Airport, where they flew over the runway and turned back to Brantford.
Tilsonburg traffic, India November Sierra, turning left base runway 26, will be overshooting the runway, climbing to 3,000 feet, making a right-hand turn and departing to the east.
Look, it's like perfect squares of trees.
On the way back, Angelica inquired about the possibility of flying with the window open.
What happened if we open the window?
Sensing that Natalie was getting a little bored, Captain Hardapple offered her a chance to take the controls. Of course, he was sure to play a little trick on her using the aircraft's rudder pedals.
Why don't you head south for a bit? Whoa, what did you do? It was me, don't worry. I did it with my feet, you see? I can just kind of...
You scared me! I thought Natalie killed us! I know, I thought I did something. Man,
As the group approached the Brantford airport, they couldn't believe their eyes. The airport's 3 runway strips form an equilateral triangle. Obviously, the girls immediately thought of the mathematics they were learning at school. Looking at a diagram of the Brantford airport, we see that the 3 landing strips indeed form an equilateral triangle. Using your knowledge of angles, can you determine the angle that the extended runway makes with the triangle? Hopefully, you found that the angle is 120 degrees. If not, be sure to take a look at the full solution to this problem later in the video. After a successful expedition, the team landed in Brantford. Although Captain Hardapple was happy to pilot the plane free of charge, the group still needed to pay the local flying club for the rental of the aircraft. As the girls headed into the terminal building to pay the bill, they were yet again reminded of how the mathematics they were learning at school played a role in their aviation adventure. The group ended up using the plane for a total of 1.3 hours. The flying club charges a rental rate of $150 per hour, but is currently offering a 5% discount on all rentals. Can you determine the total cost of the rental, including the 13% tax? If you found that the total cost is $209.33, well done. If you're not sure how to calculate this answer, take a look at the full solution to this problem later in the video. It was a rewarding day for Angelica, Jocelyn, and Natalie. Within a matter of hours, they were able to witness firsthand how their classroom mathematics can be applied to real life. As they review the results of their investigation, they're already thinking of their next mathematical adventure. In the first problem, we were told that the aviation map uses a scale of 1 to 500,000. We were also told that using a ruler, Angelica measured the distance from the Brantford Airport to the Tilsonburg Airport to be 8 centimeters on the map. Finally, we were asked to determine the actual distance between the airports and express our answer in kilometers. Now, before we begin making calculations, let's just recall what a scale of 1 to 500,000 means. It means that a distance of 1 centimeter on the map is actually a distance of 500,000 centimeters in real life. You don't have to use centimeters, though. For example, if you measured a distance of 1 inch on the map, that would correspond to a distance of 500,000 inches in real life. Now we know that Angelica measured a distance of 8 centimeters on the map. The real-life distance would be 500,000 times bigger than this 8 centimeters. So to find the real-life distance, all we have to do is take Angelica's 8 centimeters and multiply it by 500,000. This gives us a real-life distance of 4 million centimeters. Now in the question, we were asked to express our final answer in kilometers, but before we do that, let's just consider one more way in which we could arrive at this 4 million centimeters, and that method is to use a proportion. So for example, we could set this proportion up as follows. 1 on the map is to 500,000 in real life, as 8 on the map is to x in real life. And of course, our goal is to find the value of x, this real life distance here. Now remember that when we set up a proportion like this, the cross multiples are equal. That is, if we multiply 1 times x, which is simply 1x, we should get the same result as if we were to multiply 500,000 by 8. Now 1 times x is just saying 1x, so we can rewrite that as simply x. And 500,000 times 8 is 4 million. So x equals 4 million, which we saw earlier. That's this 4 million centimeters here. So moving on, we need to convert this distance of 4 million centimeters into kilometers, as requested in the question. To do this, let's first start by converting 4 million centimeters into meters. Recall that in 1 meter, there is 100 centimeters. So to find out what 4 million centimeters is in meters, we need to divide 4 million by 100. This gives us a result of 40,000 meters. Now our last step is to convert this measurement into kilometers. Remember that in 1 kilometer, there are 1,000 meters. So to convert our distance of 40,000 meters into kilometers, we simply need to divide 40,000 by 1,000, which gives us a final answer of 40 kilometers. Therefore, we can say that the distance from the Brantford Airport to the Tilsonburg Airport is 40 kilometers. In the second problem, we are told that the initial altitude of the aircraft is 815 feet above sea level and that it climbs at a rate of 900 feet per minute, as shown here on the instruments. The first part of this problem asks us to create an algebraic equation to model the aircraft's altitude while it is climbing. Now this equation will be a linear equation since the aircraft is climbing at a constant rate. And in order to find a linear equation, we need 2 pieces of information. We need a start value and a rate. We'll begin with the start value. if we look at the information above, we see that the initial altitude of the aircraft is 815 feet above sea level. That's a start value. It's an initial altitude. So our start value is 815 feet. Our rate is also given in the information above. We see here that the aircraft climbs at a rate of 900 feet per minute. So our rate is 900 feet per minute. This is all the information we need to create our equation. We are creating an equation for altitude, which is based on the number of minutes that have passed, the amount of time. So we need to choose some appropriate variables. A good letter to represent altitude would be A, and to represent time, we will use T. So our equation is A equals 815 plus 900T. That is, the altitude starts at 815 and increases by 900 every minute. Okay, once more, the altitude starts at 815 feet and increases by 900 feet for every minute that passes. Moving on to the second part of the problem, we are asked to use our equation to determine how high the plane would be if it had climbed for 10 minutes. So we'll start by rewriting our equation, which is A equals 815 plus 900T. Now we're asked to find an altitude, specifically the altitude after 10 minutes of climbing. Now this 10 is a time value. It's the number of minutes that have passed. So we can substitute 10 for T in our equation since T represents time. So in the next line, we'll rewrite the equation, but instead of T, we'll write a 10 in brackets. Now to find our altitude after 10 minutes, we just need to evaluate this expression. And when you do that, don't forget to use the correct order of operations. We must do this multiplication here, 900 times 10, before the addition. Now 900 times 10 is 9,000, so we can rewrite this as 9,000. And finally, we can add the 815 and the 9,000 to give us a final answer of 9,815 feet above sea level. And that is the altitude after 10 minutes of climbing. Okay, now let's consider the third part of this question. Once again, we have our equation, which is A equals 815 plus 900T. And in the third part of this problem, we are asked to use our equation to determine how long the aircraft must climb in order to reach the desired altitude of 3,000 feet above sea level. We'll begin once again by rewriting our equation, which is A equals 815 plus 900T. Now in this question, we're given an altitude value, 3,000 feet. So in our equation, we can replace A, which is the altitude, with 3,000 feet. In the previous problem, we were given a value for time, which is why we changed this time value to 10. But since 3,000 is an altitude, we'll go ahead and rewrite our equation, but instead of writing A, this time we'll write 3,000. Our whole goal now is to find the value of T. We need to solve this equation for T. And T is going to represent the time it takes to reach 3,000 feet. So in order to do this, we need to isolate T by getting rid of everything around T. And we'll start by getting rid of the 815. We can do that by subtracting 815. But if you subtract 815 on the right side of the equation, you know you must also subtract 815 on the left side of the equation. So on the right side of the equation, we have 815 minus 815, which is 0, so we can eliminate that altogether. And on the left side of the equation, we have 3,000 minus 815, which gives us 2,185. And that is now equal to 900T, which is the only thing left on the right side of the equation. Our last step in isolating T is to get rid of this 900. Now this is 900 times T. So to get rid of the 900, we'll use the opposite operation of multiplication, which is division. So we'll get rid of times 900 by dividing by 900, But once again, if we do that on the right side of our equation, we must do the exact same thing on the left side of the equation. So we'll divide by 900 there as well. On the right side, we get 900 divided by 900, which is just 1, so we can cancel those out, leaving us with just a t. And we can use our calculator to figure out what 2,185 divided by 900 is. We should get about 2.4 equals t. And that's our final answer. So therefore, it will take approximately 2.4 minutes to reach an altitude of 3,000 feet. For the third problem, we are told that the aircraft cruises at a speed of 200 kilometers per hour. We are asked to determine how many minutes it will take the group to cruise 40 kilometers from Brantford to Tilsonburg. We'll solve this problem using a proportion. But before we set up our proportion, notice that the speed is given in kilometers per hour. But the question asks us how many minutes it will take to cruise 40 kilometers. It would be really nice if we could set up the proportion in minutes instead of hours so that our answer will already be in the correct unit. Now, 200 kilometers per hour means 200 kilometers in 60 minutes. So when we set up our proportion, we can say 200 kilometers is to 60 minutes as 40 kilometers is to x minutes. And our goal is to figure out the value of x, that is the number of minutes corresponding to a 40-kilometer trip. Remember the importance of being consistent when you set up a proportion like this. That is, if we decided to put the kilometer value in the numerator of this fraction, that is on the top, we must also put the kilometer value on the top of this fraction. We have our minutes in the bottom here, so this value will represent minutes as well in the bottom. Okay, so let's go ahead and solve this proportion. Remember that the cross multiples in a proportion like this are equal. That is, if we multiply 200 by x, which just gives us 200x, we should get the same result as when we multiply 60 by 40. Now 60 times 40 is 2,400, so we can rewrite that. And our whole goal now is to just isolate x. So we need to get rid of this 200. Now on the left side of our equation we have 200 times x, so we'll use the opposite operation of multiplication, which is division. So if we want to get rid of times 200, we'll divide by 200. Of course, if you do that on the left side of the equation, you must also do the exact same thing on the right side of the equation. On the left side of the equation, we have 200x over 200. So these 200s divide, giving us 1. We can just cancel them out, which leaves us with just x on the left side of the equation. And on the right side of the equation, we get 12 when we divide 2,400 by 200. That is the value of x. It is already in minutes, so we can say, therefore, it will take 12 minutes to cruise 40 kilometers from Brantford to Tilsonburg. Our fourth problem deals with angles. We are told that the 3 runways at the Brantford Airport form an equilateral triangle. We are then asked to determine the angle that the extended runway makes with the triangle. That is, we are asked to determine this angle. To begin, we remember that the interior angles of a triangle add up to 180 degrees. That is, these 3 angles in the triangle add up to 180 degrees. But since this is an equilateral triangle, each of these 3 angles is the same. So we can determine the value of each of these angles by dividing 180 degrees by 3. This gives us 60 degrees, which is the measurement of each angle in our equilateral triangle. To find our angle in question, recall that the angles in a straight line add up to 180 degrees. This red line is a straight line. Therefore, 60 degrees and our angle in question must add up to 180 degrees. So we can find our angle in question by taking 180 degrees minus 60 degrees, which gives us a value of 120 degrees. Therefore, 120 degrees is the angle between the extended runway and the triangle. Problem number 5 deals with the cost of renting the aircraft. We are told that the group ended up using the plane for 1.3 hours. We are also told that the flying club charges a rental rate of $150 per hour, but that they're also currently offering a 5% discount on all rentals. We're asked to determine the total cost of the rental, including 13% tax. So we'll start by calculating the initial cost. We know that the group used the plane for 1.3 hours and that the flying club charges $150 per hour. Therefore, our initial cost will be $150 per hour times the 1.3 hours, which gives us $195. Now let's consider the discount. We know we have a 5% discount. So we'll start by writing that as a decimal, which can be done by calculating 5 divided by 100. This gives us 0.05. To find the discount, we take this 0.05 and we multiply it by our initial cost of $195. Multiplying this 195 by 0.05 gives us $9.75. This number is 5% of our 195. That is to say, this $9.75 is our discount. Now, since it's the discount, we need to subtract it from the cost. So we can get our new discounted cost by taking $195 minus $9.75, and that gives us a discounted cost of $185.25. So this is our cost after the discount has been applied. We can now find the total cost by considering the tax. Now we know that the tax is 13%. So once again, we'll start by changing 13% into a decimal. And we do this by dividing 13 by 100. This gives us 0.13. To find the tax, we take our cost and multiply it by this 0.13. Now our most recent cost is $185.25. That's the cost with the discount. So we multiply that by the 0.13, and that gives us a value of $24.08. This is the amount of tax that we have to add to the cost. And that's how we find our total cost. We take our $185.25 and we add our tax to it, which is $24.08. That gives us a total cost of $209.33. So, therefore, the total cost of renting the plane is $209.33.